All right, welcome back to geometry. Today we're going to take a look at section 12.2 dealing with surface areas. And we'll be considering the surface areas for two shapes to start with, prisms and cylinders. So we'll define each of those two shapes, a prism and a cylinder, for you, and then show you how to go about finding the surface area of that solid. Okay, so a prism is defined to be a polyhedron with two congruent faces that are called bases, and the bases are going to have to be parallel to each other. So in the picture that I've drawn for you guys here, we have a prism, and the two congruent faces are the triangle on the front and the triangle on the back. So what we're saying is those two triangles are congruent to each other, so exactly the same sides and exactly the same angles, and they're also parallel to each other. Okay? So if those two things are true, then it's called a prism. And the congruent faces are called bases. Please notice I put that in parentheses here. The congruent faces are called bases. So, and then I put an asterisk here for bases. And I'm just going to remind everybody that the bases are the congruent faces, and the lateral faces are always going to be rectangles which connect the bases. And it's kind of hard to draw because they're at kind of a crazy angle, but we'd have a lateral face that would make up the slanted right-hand side of this prism. We'd have a rectangle that forms the bottom, connecting the two triangles. And then we'd have a rectangle that would connect the two left-hand sides of the triangles. So those are called lateral faces. Now, the two measures we're going to be looking at are surface area and lateral surface area. Now, whenever you say just surface area, we're going to find the sum of the areas for all the polygons that make up a prism. Okay? So we're going to sum all, where's there? There it is. We're going to sum all the areas for all of the polygons. Now, if we ever are asked for just lateral surface area, that's going to be the sum of the lateral faces, so just the rectangles that kind of connect the bases. There's going to be times when we only want lateral surface area as well. Okay, now how to make these calculations? How do we find the surface area for something like a prism? Well, one idea is to use what's called a net. And a net really is just a three-dimensional solid. So here's an example. I started you guys off with a rectangular prism, or you guys might just think of it as a box. And what we do is we pretend that the sides of the box are just cardboard. And if we cut the tape that usually holds the sides together, if we cut those pieces of tape and just lay it flat, we create what's called a net. We create what's called a net. All right? And that's one way in which we can find a surface area, is to pretend that our three-dimensional solid is a cardboard box. We cut the pieces of tape that hold it together and unfold it, lay it flat, and we create what's called a net. And then the idea would be that we could calculate surface area, which I'll just abbreviate as SA here, by looking at the shape that's been flattened out the net and just adding up all of the individual areas. As an example, I could think of this as a big square in the middle. And I know it's a square because it's 12 centimeters on this side, and then because this dimension is 3, all of these coming down the side would be 3. So 3, 3, 3, and 3 would make this side 12. So the area of that huge middle, I should say, that huge middle section would be 12 times 12. And then what we'd have to do is add the two areas for these little shapes that are kind of poking out on the sides. And those you can see are squares, you can tell by the tick marks. And so these little squares are going to be 3 times 3 for area. So our surface area would be 12 times 12, 144, which would get us the area for the big middle section. And then 2 times 3 times 3, or 18, for the area of the little square on this end and the little square on that end. And when we put those fellas together, 144 and 18 is 162. And because we're measuring an area, our units are going to be in square labels. So in this case, square centimeters. Okay, let's try another one. If I took a cylinder, and my cylinder isn't really good, I forgot to kind of draw the back side of the there, and my circles are looking a little shaky. But if we started with a cylinder, guys, and again pretended that this was kind of a crazy box, and we cut the tape that was holding this fella together, and we laid it flat, this would be the net. We'd end up with a rectangle. We'd end up with a rectangle that was the side, the lateral face. Okay, that would become the rectangle. And then we'd have a circle that was the top and another circle that was the bottom. And so the idea, guys, would be that to calculate surface area, we could then find the area for each of those 3 shapes. The area for the top circle, the area for the rectangle, and the area for that other circle. Now we know the area of a circle is pi times the radius squared. Now what they've given us in the problem is the diameter. So if the diameter is 10, that means the radius is 5. And since the top and the bottom, the bases have to be congruent, if the radius of the top is 5 feet, the radius of the bottom is 5 feet as well. Let me make my 5 a little nicer there, guys. There we go. Okay, so we have the area, we just need to punch it out, of course. We have the area for the top circle, the area of the bottom circle. Now all we need is the area of the rectangle that made up the side. And of course, the area of a rectangle is just length. I'll put a L above, and width, length and width. Well, they show us one value. They say the width of that rectangle is 6. But what would the other measure be? What would the length be? In fact, let me put it maybe in blue. What would the length be for that rectangle? What would that length actually end up being? Well, if you think about where the rectangle came from the lateral side. The length of that rectangle is actually going to be the same as the circumference of the circle. And we know that the circumference of a circle is 2 times pi times r. So what we can then do is put in 2 times pi times r for the length of the rectangle. Okay? And then I'm going to show you this answer, both exact and approximate. Pi times 5 squared is 25 pi. 2 times 5 times 6, let's see, what is that, 1060 pi. And then again, I'd have a 25 pi there. So my exact answer would be 25 pi's plus 60 pi's plus 25 pi's, and I think that's 110 pi's altogether. Or if you'd rather approximate it on your calculator, 110 times pi, let me punch it out for everybody, gets me about 345.6, about 345.6. And both of those answers, whichever you choose, the exact or the approximate, would then be measured in square feet. All right? So that's one way to do it, is to think of whatever this solid is as a box made of cardboard, cut the tape away, fold it flat, creates what's called a net, and then try to find the sum of the areas of the net. Okay? Not real efficient though, and sometimes a little bit hard to figure out what the net might look like. So therefore we have 2 theorems. The first one, number 12.2, is the theorem that gives us the surface area of a right prism. Okay? And there's 2 versions of it depending on what the base looks like. It either is this, 2 times the base, plus the perimeter times h, or a times p plus p times h. And I just have to tell everybody what these fellas are. Capital B represents the area of a base. P represents the perimeter of a base. H is the height between bases. And the only letter we're left with that we don't have yet is little a. And little a is the apothem. So depending on the shape that's given, we'll either use the first version, 2b plus ph, or we'll use the second version, a times p plus p times h. Okay? So please make sure you get the 2 parts of the formula down for the surface area of a right prism. All right, guys? And so let's take a look at a couple of examples then. All right? If I asked you to find the surface area for this triangular prism, would you guys be able to do that? Okay, I'm going to abbreviate that as SA for surface area. And I'm going to choose to use this formula, 2b plus ph. So what I'm going to need you guys to help me with is 3 values. We need b, which is the area of a base, plus p, which is the perimeter of a base, multiplied by h, which is the height between the bases. So we need 3 values, capital B, capital P, and little h. We need those 3 values, okay, to calculate the surface area for this prism. Alrighty, so capital B is the area of a base. And remember, a base is one of the polygons that are both congruent and parallel to each other. So in my picture, the 2 triangles are going to be the bases. So do we know how to calculate the area of a base? In this case, the area of a triangle? Well, heck yeah. The area of a triangle is going to be 1/2 times the base times the height. So in our case, the base is 8 and the height is 5. So the area of one of the bases is 1/2 times 8 times 5, which is going to get us 20. So capital B is 20. P is the perimeter, I'll underline that, is the perimeter of a base. And how do we calculate a perimeter? We add up all of the sides. So for a triangle, we'd have to add up, in fact, I'll write it out here just so everybody's really clear. What we'd have to do is we just have to add up the 3 sides. We'd have to add up the 3 sides. All right? Now we have 2 sides given to us in the picture, 8 and 5. What we don't know is the 3rd side right off the bat. Okay, we don't know the 3rd side. They don't tell us the 3rd side in the problem, in the picture. So how are we supposed to find it? Well, what I need you to observe is that we have a right triangle. And anytime we have a right triangle and we know 2 out of the 3 sides, we can use Pythagorean theorem to find the 3rd side. Please notice the 3rd side is across from the 90-degree angle, so it is the hypotenuse. So Pythagorean theorem is going to be leg squared plus leg squared equals the 3rd side squared. And we just need our calculators. 5 squared is 25. 8 squared is 64. 25 and 64 is 89. And then to get rid of the power of 2, we take the square root of both sides. So the 3rd side then is going to be approximately 9.4 long. So that 3rd side is approximately 9.4. And therefore the perimeter is 8 plus 5 plus 9.4. What does that get me, guys? 22.4 approximately for the perimeter. So the perimeter is approximately 22.4 feet. And finally, the h is the perpendicular distance between the bases. And you can see the distance between the bases is given to us in the problem. That distance is 12. So we have all three of the values we need: the area of a base, the perimeter of the base, and the height between the bases. And therefore the surface area then is going to be 2 times 20 plus 22.4 times 12, which is 268.8. And then, excuse me, when we add those fellas together, we should get, I believe, 308.8 square feet. And that would be the surface area for this triangular, for this triangular prism. Okay? Now let's look at one that appears to be a bit tougher, but the idea is going to be the same. We want to calculate the surface area for this shape. Now, because the base, the top, and I don't want to draw a whole bunch of lines on it because we're going to need to do a little bit of work, but I'll shade in the bottom at least. The bottom and the top are going to be regular pentagons, five-sided shapes, regular pentagons. Okay? Now, because we're going to need to know the area of a base, I'm going to then choose the second version of the formula, which is A times P plus P times H. Right? I'm going to use that version. And here I'm going to need, again, three numbers. I need the apothem for the base, the perimeter of the base, the perimeter of the base, of course I need that same value twice, and then the height between the bases. So again, I need three numbers. One of them I just used twice. I used the perimeter 2 times. But I need the apothem, the perimeter, and the height. Now, a couple of these fellows are really easy. The height between the bases, the height between the top and the bottom, is given over to the left-hand side. The height between the top and the bottom of this prism is 6. So that one's really, really, really simple. Another one that's pretty simple is the perimeter. And it's pretty easy because all of the sides of the pentagon are the same. So if that given side is 5, that side is 5, and that side is 5, and that side is 5. And I'm going to not draw the one right in the front, but that other side, let me just draw it across, I guess. That side that I just drew in would also be 5. So 5, 5, 5, 5, 5 would get us a perimeter then of 25. All right? So for the three values that we need, we can get two of them awful doggone easy. There's only one that's very difficult at all, and that's the apothem. And I'm going to choose to draw that in blue just so it stands out a little bit. That's the fella that I need. If you don't remember, the apothem is the distance from the center perpendicular to one of the sides. Okay, and how are we going to be able to find that? Well, if I take the triangle formed here, guys, if I take the triangle formed and pull it out and draw it a little bigger so it's easier to see, and then just clean that up a little so it's not quite so ugly. Okay, so that's the blown up, a zoomed in version of that triangle. And what they show us in the picture is that this side of the triangle is 4. This is the apothem that we're trying to find. I'll use a little a for that. And my question to everybody is, would we know how long this third side is, this horizontal side? And the answer is yes. Because we know all of the sides of the polygon are 5s, all the way around. Remember, we use that for the perimeter. When we draw this perpendicular down, that always cuts that side into 2 equal chunks. So if the whole side is 5, that's going to make this piece 2.5, half of 5. And then what that gives us is 2 out of the 3 sides. So we could use Pythagorean theorem. Just notice that the sides across, that is across from the 90-degree angle, is the 4 here. So that's going to be the hypotenuse. So Pythagorean theorem is going to be a squared plus 2.5 squared is equal to 4 squared. And we just need our calculators to do the math. 2.5 squared is 6.25. 4 squared is 16. We move positive 6.25 to the other side by subtraction. I think I get 9.75 if I did that okay in my head. And then get rid of a power of 2 by taking the square root. So the square root of 9.75 is about 3.1. So the apothem is approximately 3.1 units long. I'll switch back to red so it doesn't look so goofy. And then we just simply have to multiply the apothem times the perimeter, so 3.1 times 25 is 77.5. And 25 times 6, what's that, 150? Yeah, so 150. And so when I add those fellas together then, 77.5 and 150 then gets me 227, yeah, 227.5. And what are we in here, centimeters? So it'd be 227.5 square centimeters. Okay? All right. So that's the idea for finding the surface area of a prism. And we just have one other shape we're concerned with here, and that's a cylinder. So first, the definition for a cylinder. A cylinder is a solid, so that just means three-dimensional. So this just means 3D, so a solid with parallel congruent circles as bases. Parallel congruent circles as the bases. And the two numbers that we're going to be concerned with, I've drawn you an example here. The two numbers we're going to be concerned with are the radius of the circle and the height between the two circles, the height of the cylinder. Okay? And then the theorem I need everybody to get down is that the surface area of a cylinder is going to be given by 2 pi r squared plus 2 pi rh. And I'm just going to make two notations here around our theorem. The 2 pi rh is going to be the areas of the bases. In fact, let's be more specific there. Let's call that instead the area of the circles. So 2 pi r squared is the area of the circles, and 2 pi rh is going to be the area of the side. Now, technically, I should probably call that the lateral side, but I think hopefully you guys have the idea. That would be the rectangle formed around the side of that thing. Okay? Alrighty. So with that there, and feel free to pause the video if you need a little more time to jot that down. Let's calculate a couple of surface areas then. All right, so if I have a can of motor oil, where the radius of the top is 5 centimeters and the height is 15 centimeters. So if I were to try to attach those to the picture, the height 15 centimeters and the radius of the top is 5 centimeters. What the formula says is the surface area for the cylinder then is going to be equal to 2 pi r squared plus 2 pi r h. And what you'll find, it looks kind of complicated, but really we only need two values. We need the radius of the top and the height between the top and the bottom. That's all we need. So in a problem like this, we just are told that the radius is 5, so I can replace r with 5. And we're told that the height is 15. I can then replace h with 15. And that's all there really is to it. And I'll give you guys this as both an exact answer and an approximate answer. 5 squared is 25, and 2 times 25 is 50. 15 times 5 is 75, and 75 times 2 is 150. So the surface area for this can would be 200 pi square centimeters. That would be the exact answer. Or if you'd rather have the approximate answer, 200 times pi is approximately 628.3. 628.3 square centimeters. Okay? So even though the formula looked pretty complicated, really there's just two values you need. Radius in two different places, I'll connect those, and height. Those are the only two values you need. So I hope those aren't going to be too difficult, as long as you have the formula in front of you. You know, the formula in your notebook. Hopefully that won't be too bad. Okay? So that's it for this video. Go ahead and stop this one. Get a little break, take a little walk, have a little snack, and then go ahead and open up your books and get started on section 2. Hope you're doing well, and I hope to see you guys soon. See you later.